Example 3 of graphing quadratics without the y equals function on your calculator. So this time we only have two terms in our problem, which means that it's probably going to be a difference of squares. But the first thing I want to do is identify the a, the b, and the c of my quadratic so that I can find the vertex using negative b over 2a. Well, the a value is negative 1. The b value is 0. There is no regular x in this problem, so it's 0. The constant is 9. So that means when we plug this in, it goes negative 0 divided by 2 times negative 1. And anytime you've got a 0 on the top part of your fraction, your answer is 0. So that means that our axis of symmetry is x equals 0, which just so happens to be the y-axis this time. So I'm going to draw that in, and that's my axis of symmetry, x equals 0. So now that we've got the axis of symmetry, we can take that number and plug it back into the original problem. So y is equal to negative 0 squared plus 9, and that gives me a y value of 9. So now I've got the vertex point of my parabola, and I can go ahead and put that on my y-axis. Once you've got your vertex, now you're going to take that problem, so the negative x squared plus 9, all I did was leave off the y equals part, and you are going to factor it. Now when you've got that negative sign in the front, you're going to do the same thing that we did on example number 2. You divide out a negative 1, which gives us x squared minus 9. And now it is a difference of squares. We have a subtraction problem between two terms with perfect squares because the square root of x squared is x and the square root of 9 is 3. So now we've got the problem x plus 3 and x minus 3. We've got our problem factored, so now we can say x plus 3 equals 0 or x minus 3 equals 0. And for the first one, when I subtract the 3, that gives me an x-intercept of negative 3. And on the other one, I'm adding 3. I've got an x-intercept of positive 3. So now that I know where we cross the x-axis, I can plot those points. And that kind of gives me a good idea of what other x values I need to plug in to finish my parabola. Because I've got one at negative 3, I could plug in negative 4, but I don't really think that's necessary. Let's deal with that x value and that x value. So we've got 1, 2, 3 points on this side of that axis of symmetry. So I'm going to do x equals negative 2 and x is equal to negative 1. And you're just plugging it back into the original equation, negative x squared plus 9. So that means y is equal to negative 2 squared plus 9. If I type that into my calculator, double negatives, gives me positive 5. So we have a y value of 5 when our x is negative 2, so that's that first ordered pair. Now we're going to do the same thing and plug in negative 1. So negative 1 squared plus 9. If I type that one in, that gives me positive 8. So y equals 8, and that's the point 1 comma 8. Actually negative 1, because that's my x value. So now I've got my 2 points. I'm going to plot them. Negative 2 positive 5 is right here, and negative 1 positive 8 is there. Instead of plugging in more x values, now we can just reflect those points across the axis of symmetry. There's 1 to the left and 1 to the right. 1, 2, 1, 2, put a point there. And now I've got enough of my picture that I can connect my points of my parabola with a curved line.